787 feet. That's the height of a modern wind turbine. The surprising part is that this giant machine spins so slowly that you can almost follow each blade with your naked eye. Yet, despite that slow, steady rotation, it can still generate enough electricity to power thousands of homes every year. So where does that incredible power come from? How can an invisible stream of wind be transformed into the electricity that lights up an entire city? Today, we're going to take a complete journey inside a wind turbine to find out. The idea of harnessing the wind dates back about 5,000 years, when people used sails to travel along the Nile River. By around the 7th century, the first windmills appeared in Persia, where they were used to grind grain and pump water without relying on human or animal power. The real breakthrough came in the late 19th century, when engineers began exploring how wind could be used to generate electricity. In 1887, Professor James Blyth in Scotland built one of the world's first wind turbines for producing electricity. Just 1 year later, Charles F. Brush in the United States built a larger turbine to supply power to his own home. From those simple machines, wind turbines have evolved into towering structures hundreds of feet tall, capable of generating enough electricity for thousands of homes. So what makes that possible? Let's begin by looking at the structure of a modern wind turbine. From a distance, a wind turbine looks simple. Just 3 blades mounted on top of a tall tower. But in reality, it's one of the most sophisticated mechanical machines ever installed outdoors. A modern wind turbine can stand nearly 800 feet tall, with each blade stretching more than 300 feet long. Despite their enormous size, the blades are made from fiberglass and carbon fiber, making them both lightweight and incredibly strong. They can also bend slightly in high winds, reducing stress and helping prevent damage. The 3 blades are connected to a central component called the hub, forming the rotor. Behind the rotor sits the nacelle, the main housing that contains the drive shaft, gearbox, generator, braking system, and the sensors that control the entire turbine. If you think of a wind turbine as a living body, the blades are like its arms, capturing energy from the wind, while the nacelle serves as both its heart and brain, managing everything happening inside. What makes a wind turbine spin isn't the wind simply pushing against the blades like a pinwheel. The real secret lies in the shape of the blades themselves. Each blade is designed using the same aerodynamic principles as an airplane wing. As air flows over the blade, it moves faster across one side than the other, creating a difference in air pressure. This generates lift, a force that pulls the blades around instead of just letting the wind push against them. Together, the 3 blades generate enough lift to rotate the rotor. This is the first step in converting the wind's kinetic energy into mechanical energy. But a spinning rotor is only the beginning. To produce electricity, that rotating motion must be transferred deeper into the turbine. The rotor is directly connected to the main drive shaft located behind it. As the rotor spins, it turns this shaft as well, transferring all of the mechanical energy into the nacelle at the top of the tower. Although the rotor rotates at only about 10 to 20 revolutions per minute, the main drive shaft must handle an enormous amount of torque. That's why it is made from high-strength steel and built with a large diameter, allowing it to operate reliably for decades. If the rotor were connected directly to the generator, the turbine would produce very little electricity. The reason is simple: the rotor spins too slowly. That's where the gearbox comes in. Inside are multiple stages of gears with different sizes. carefully arranged to increase the rotational speed. As the low-speed drive shaft enters the gearbox, each gear stage reduces torque while increasing rotational speed. After passing through several gear sets, the speed can rise from about 10 to 20 revolutions per minute to more than 1,000 revolutions per minute, fast enough for the generator to operate efficiently. What's remarkable is that this entire process has to run almost continuously in all kinds of weather. That's why the gearbox is constantly lubricated with oil and monitored by sensors that measure temperature, vibration, and pressure, allowing potential problems to be detected long before a failure occurs. Once the speed has been increased, the high-speed shaft delivers that rotation to the most important part of the turbine, the generator. After passing through the gearbox, the rotational speed has been increased and is delivered to the generator. Inside the generator are two main components: the rotor, which spins, and the stator, which remains stationary. As the high-speed shaft turns the rotor, its magnets rotate continuously around the copper coils inside the stator. This changing magnetic field induces an electric current in the coils. This process is called electromagnetic induction, the same basic principle used in most power plants around the world. What's remarkable is that the generator doesn't create electricity from fuel. Instead, it simply converts the mechanical energy of the spinning shaft into electrical energy. A modern wind turbine can produce several megawatts of power, although its actual output constantly changes depending on the wind speed. A wind turbine doesn't simply spin freely with the wind. Every movement is managed by an automated computer control system. Sensors mounted on top of the turbine constantly measure the speed and direction of the wind. If the wind changes direction, the system rotates the nacelle so the blades continue facing directly into the wind. The angle of each blade is also adjusted continuously. When the wind is weak, the blades are pitched to capture as much energy as possible. When the wind becomes stronger, their angle is changed to reduce the force on the rotor and keep it spinning at a safe speed. At the same time, the control system monitors the temperature and vibration of the turbine's internal components. If it detects any signs of abnormal operation, it can automatically slow the turbine down or shut it off completely to prevent damage. A wind turbine doesn't operate in every weather condition. When the wind exceeds a safe limit or the system detects a problem, the turbine automatically shuts down to protect itself. The first step is to rotate the blades out of the wind, reducing the aerodynamic force and allowing the rotor to slow down gradually. Once the rotor reaches a safe speed, a mechanical brake is applied to bring it to a complete stop and hold it in place. Most modern wind turbines automatically shut down when wind speeds exceed about 55 miles per hour. Once conditions return to normal, the control system restarts the turbine automatically, allowing it to resume generating electricity without any human intervention. The electricity generated inside the turbine isn't ready to be sent to the grid right away. First, it passes through a transformer located inside the tower or near the base of the turbine, where its voltage is increased. Higher voltage reduces energy loss during long-distance transmission. From there, the electricity travels through underground cables, connecting multiple turbines before being collected at a substation. At the substation, the electricity is adjusted to match the requirements of the national power grid. It is then transmitted across tens or even hundreds of miles to cities, factories, businesses, and millions of homes. And that's the end of a journey that began with nothing more than a breeze. After just a few stages of energy conversion, the wind has been transformed into the electricity we rely on every day. After leaving the wind farm, the electricity travels through high-voltage transmission lines, sometimes covering hundreds of miles. Along the way, it passes through a series of substations where the voltage is gradually reduced to safer levels. First, the electricity is stepped down for the regional transmission network. Then, it enters the local distribution system that serves towns and cities. Finally, a transformer near your neighborhood lowers the voltage to about 220 volts, making it safe for household outlets. What's truly remarkable is that this entire process happens almost instantly. Just moments after the wind begins turning the blades, that energy can already be flowing through the power grid, lighting your home, running your appliances, and powering everyday life. Wind is nothing more than moving air, but when it flows across a set of giant blades, it can drive an entire mechanical system, generate electricity, and deliver that energy to millions of homes. What's truly remarkable isn't just the size of these turbines. It's the way engineers have learned to turn something invisible into a reliable source of electricity that we use every single day. And as the world needs more power while reducing its dependence on fossil fuels, wind turbines are likely to play an increasingly important role in the future. If you had to choose one energy source for the future, which would you pick? Wind, solar, or nuclear power? Let us know why in the comments below. And if you enjoyed this video, don't forget to subscribe and turn on notifications so you won't miss our next one.